Hello, algebra student. We continue with Unit 4, Lesson 4, which we are breaking into 2 days. This is going to be a 2-day lesson, so I'm going to record part of it right now in this video, and then we'll come back to Lesson 4 in Unit 4 and do a second video. So 2 days. Hopefully these are shorter videos than the previous videos for this unit. I know they get long, and I know that that's frustrating. We are going to learn how to graph linear equations today, not by using the slope and y-intercept. Nope. We're going to learn how to graph equations today using things that are called intercepts, meaning the y-intercept and something called the x-intercept. Now, the deal is you have to calculate the intercepts. You actually have to do some algebra for each linear equation, and you have to do it twice. Then one answer will become your x-intercept, which is where your line crosses through the x-axis. And the other calculation, the other answer, is going to become your y-intercept, which is where your line crosses through the y-axis. This actually isn't all that bad. It looks terrible. It sounds like it's a lot of work. It's really, really not. Most kids do rather well with calculating x-intercepts and y-intercepts. So, will you need a calculator today? You might. You might not. I don't know. It just depends on how good you are at mental math. Here we go. So again, we've already learned how to graph a linear equation using the slope and the y-intercept. But today, we're going to graph using the x-intercept and the y-intercept. So easy, I think. Step 1. The equation has to be in standard form. Let's remember that this is standard form. It's ax plus by equals c. It's when your x term and your y term are on the left side of the equation. This is that standard form. Now, a couple videos ago, I told you about standard form, and I said it's really only convenient for this one particular thing. And that one particular thing is this: calculating the x-intercept and the y-intercept. Don't worry about all this. This would just confuse you if I tried to explain it. Let's go over the steps of how this is done. The first thing it says to do is it asks you to cover up the y term and solve for the x, and that's going to become your x-intercept. Now, they talk about covering up the y term, and that's definitely one way you can do it. Another thing to make the y term go away is to plug in a 0 for the y. Now, I'll show you in a minute what I mean. But yeah, you can basically just take your finger and cover up the y term like this, and then solve that. You'll be solving for x, and that'll tell you what's called your x-intercept. You could also, like I said, you could plug in a 0 here, because any number times 0 is 0, which again makes it go away. So whether you plug in a 0 for the y or you just simply cover it up with your finger, but if you cover up that y term and solve for x, you're going to end up with x equals something, and that's your x-intercept. You'll see. Now, then we go back to the equation and start over. And this time you're going to cover up the x term and solve for y. And that would then become your y-intercept. So you would go here, cover up the x term, solve for y, and that would be your y-intercept. Another way you might hear this taught is to plug in a 0 for the x, because anything times 0 is 0. Again, basically making it become invisible. So it's just a way of manipulating the standard form equation so that we get our x-intercept and y-intercept. We plot those 2 points. We draw our line. It's actually quite simple. I think you'll like it. Let's start here. 3x minus 2y equals negative 6. Okay, if I want the x-intercept, I cover up the y, which I can't do very easily. I'm afraid I'm going to block the whole thing. And this is what I would have. It would say 3x equals negative 6. So the y term goes away, and we solve for the x. Divide by 3, divide by 3. x is -2. This is my x-intercept. That means on the x-axis, I find where -2 is, which is 2 to the left of the origin, and I put a dot. Now I want to do the same thing all over again, but this time I cover up the x term and I focus on the y. Look at all these marks on my hand from, isn't that, I'm not dirty. It's just marker from grading and recording and whatnot. So sorry, I know I look a hot mess. Anyways, back to the problem. Cover up the x term. Keep in mind that subtraction right there belongs to that 2y, so it's now -2y equals -6, and we're going to solve for y. So divide by -2 here, divide by -2 here, y equals +3. My y-intercept is +3. So on the y-axis, I go up +3 on the origin, I put a dot. You have your x-intercept, your y-intercept, you draw the line. It's actually quite simple. It, in my opinion, is the only thing standard form is good for. It's good for calculating x and y intercepts pretty easily. Let's do it again on number 2. I want the x-intercept, which means the y goes away. So I would cover up that chunk right. It's hard without covering the whole thing. I would cover up that piece. So it would say x equals 4, and oh, yay, look, that one's already solved for me. Nice. On the x-axis, I go over to +4 and I put a dot. For the y-intercept, the x goes away, and it says 2y equals 4. Solve for y by dividing by 2. Y is 2. So on the y-axis, I find +2, I put a dot, and then I use a pencil, or in this case, a black marker. Draw my line. Not too bad, right? I don't think it's too bad. Let's do some that are maybe a little bit more difficult. We're going to do number 6. I want to focus on the x first, so the y piece goes away. Right? So 9x equals 45. Divide by 9, divide by 9. X-intercept is +5. Now the x goes away and I focus on the y. Right? So 15y equals 45 because the x goes away. Divide by 15, divide by 15, y is 3. +3. So on the y-axis, I find +1, 2, 3. I put a dot. I connect my dots. And I've drawn my line. This is called graphing by the intercepts. Graphing by the x-intercept and the y-intercept. And again, it is the number one thing that standard form is most useful for. I didn't say that very well. What do you think? Let's do number 9. I'm going to do this one. I want to focus on the x first. So the y, the -y, we cover that up. It goes away. So it says x equals 1. Oh, yahoo. That was nice and easy. We didn't even have to really solve for anything. X is 1. Now the x term we cover up. And it says -y equals 1. Can't have that, right? So everything gets divided by -1, divide by -1. 1 divided by -1 is -1. So on the y-axis, we go down to -1, we put a dot, and connect our points. It certainly beats rearranging this into slope-intercept form, don't you think? Okay, last one, number 10. I want the x-intercept first, so the y goes away. Divide by 10, divide by 10. X-intercept is -3. 1, 2, 3 to the left of the origin. Now for the y-intercept, the x goes away, and it says 30y equals -30. Divide by 30, divide by 30. Y is -1. So on the y, we go down to -1, which is down 1 from the origin. We put our point, we connect our dots, and we have our line. Should be relatively simple. You know, you're focusing on the x term, solving, then you focus on the y term, solve it. That's your x-intercept, y-intercept, plot your dots, you're done with it. Okay? I'm going to say it one last time. Calculating the x and y intercepts is really, in my opinion, the only time you would ever really want to work with standard form. Standard form is not that great. It doesn't tell you that much about your line at a glance unless you manipulate it quickly to calculate the x-intercept and y-intercept, because then you can plot them and draw it pretty quick. But it doesn't, like if you look at standard form, it doesn't tell you anything about your slope. It doesn't tell you anything about your intercept until you work with it a little bit. But if that's what you're after, this is a pretty quick way to get it. Okay? I hope that makes sense. Of course, you're going to get practice with that. And I'll have the second half of this lesson in the next video. All right, take care.